Okay, let's dive into this. The world of JavaScript runtimes feels like it's always, chasing speed, chasing efficiency.
It really is.
Yeah.
Especially when you talk about serverless.
Right, serverless environments
Yeah.
where getting code running fast, using minimal resources. Oh, well, that's basically the whole game, isn't it?
Absolutely. Serverless just changes the performance equation completely. You're not running these long-lived processes anymore. It's often short bursts, right? So the overhead, the time it takes just to get your code ready to run, that becomes super critical.
Yeah, the dreaded cold start problem.
Always the battle.
Yeah, yeah. Okay, so that brings us neatly to this interesting new player that's popped up. We're pulling this discussion straight from the sources you shared with us, an article, and the details from the official GitHub repo.
Right.
And our mission here really is to unpack these sources, figure out what this thing actually is, why Amazon built it, how it fits in with Node.js, Duno, all the others.
Where it shines, where it doesn't.
Exactly, and its limitations, its current state. Basically give you the shortcut to getting up to speed on this new runtime contender.
And this contender is called LLRT.
LLRT.
The name gives you a pretty big clue. Low latency runtime.
Low latency runtime. Okay. So what is this thing at its core? What problem was Amazon specifically trying to solve here?
Well, based on the material we looked at, LLRT is an experimental runtime. Lightweight JavaScript runtime.
From AWS Labs, specifically.
From AWS Labs, yeah. And its purpose is very focused, designed specifically for those fast, efficient serverless applications we were just mentioning. It's built with that serverless context in mind, like from the ground up.
Got it. And the sources are pretty clear it is experimental right now. Evaluation, exploration, that sort of thing.
Definitely subject to change.
But what makes it tick? What's different under the hood? The sources point to a key technical decision that seems, well, kind of counterintuitive at first.
Yeah, this is where the interesting engineering trade-off comes in.
Yeah.
Maybe the most insightful bit from the material. So LLRT is built in Rust. Great language, known for performance, memory safety, and it uses the QuickJS engine, which is a small, fast JavaScript engine.
Right.
But here's the kicker, the critical decision. It explicitly does not include a just-in-time compiler. Node.js.
Wait, hang on. Node.js. When you think Node.js, Dino, Bun, they all use V8, right? Google's engine.
Mostly, yeah. V8's the big one.
And V8 has this incredibly powerful JIT compiler. Isn't that usually seen as the key to JavaScript speed? Why would you remove it if you want low latency?
See, that's the core insight, tailored specifically for serverless. A JIT compiler is fantastic for code that runs for a long time, right?
If it optimizes hot paths.
Exactly. It analyzes patterns, recompiles the bits that run often. But that initial compilation process itself, it takes time.
Yeah.
It uses CPU, it uses memory, it has overhead.
Okay.
Now, think about a serverless function.
Yeah.
It might only run for, what, milliseconds? A few seconds, maybe?
Right. Very short-lived.
So you pay that JIT startup cost every single time it spins up.
Right.
But you often don't run long enough to really benefit from those long-term optimizations it provides.
Ah, I see. So by ditching the JIT, you just skip that whole upfront cost on every single cold start.
Precisely. You're making a trade. You're trading potential peak, sustained throughput, how fast it runs once it's warmed up, for much faster initialization.
And that saved CPU, saved memory at startup. That means your actual application code can start running sooner.
Right. Directly tackles the cold start problem. Plus, removing the JIT just makes the runtime itself smaller, simpler, less complexity.
And that technical decision, that trade-off, it leads directly to the headline benefits the sources are talking about. The numbers look, well, pretty striking.
They really are. The runtime size, for example, the source is cited as under 2 MB.
Under 2 megabytes. Compared to Node.js, I mean, a basic Node app package can easily hit 100 bigs or more with dependencies, right?
Easily. So yeah, under 2 MB it's tiny, dramatically smaller. And that small size contributes to the reported startup speeds. The claim is up to 10 times faster startup on AWS Lambda.
10 times faster.
And the sources also suggest this could lead to up to 2x lower overall cost on Lambda, which likely comes from a mix of faster execution times and needing less memory allocated.
What you pay for, yeah. Lower memory is huge in serverless. It's performance and cost.
Absolutely. And about those cold starts, getting the function ready in milliseconds, that's the dream for anything latency sensitive.
And the Rust Foundation probably helps there too, with memory management, less garbage collection, pauses maybe.
Yeah. The sources imply that Rust's manual memory management helps avoid those unpredictable pauses you might get with traditional garbage collectors, contributing to faster, more consistent initialization.
So essentially, for the right kind of serverless job, LLRT is trying to give you the ease of JavaScript with performance characteristics more like Rust or Go.
That seems to be the goal described in the material, yeah.
Yeah.
Best of both worlds for that specific niche.
Okay, so let's place LLRT in the broader landscape. It's getting pretty crowded out there, isn't it? You've got Node.js, the established king.
Still the giant, yeah. Biggest ecosystem by far.
Then Dino, this sort of security-focused challenger.
Right, and the sources do mention Dino's performance. Like, one benchmark showed significantly higher throughput than Node in some basic tests. Better memory use, too. Plus, its security model is built in from the start.
And it's getting some real adoption, places like Netlify, Supabase.
Slack, too, yeah. A decent community building around it.
And then there's Bun, the newer kid on the block, really focused on speed.
Bun's definitely making waves.
Yeah.
Though the sources we looked at didn't really benchmark Bun against the others directly, focusing more on Node and Dino relative to LLRT.
So the key difference the sources draw is Node, Dino, Bun, they're built as general-purpose runtimes.
Fundamentally, yes. They're designed to handle all sorts of tasks, long-running servers, complex apps, you name it. And that's why they rely on JIT compilation to optimize for that sustained performance.
Whereas LLRT is making that deliberate choice not to be general purpose.
Exactly. It's specializing, trading JIT optimization for that critical serverless startup speed.
But the sources are also clear. Node.js isn't going anywhere, still very competitive.
Oh, absolutely. Especially for complex applications, things that really lean on that huge NPM ecosystem, the mature tooling, and where maybe a few milliseconds on startup doesn't matter as much as long-term throughput.
So it's not like LLRT comes in and replaces everything.
Not at all. It's more like having another tool, a specialized tool in the toolbox. It's about understanding which tool fits which job.
Okay, so that brings us to the jobs it is suited for. Where does LLRT really shine, according to the sources?
Based on that Node.js design, it's all about latency-sensitive stuff running in serverless.
Yeah.
AWS Lambda is the obvious example.
Right.
It's apparently most effective for those smaller, focused functions. Things where the JIT overhead would just be wasted time and resources on every invocation.
Like what kind of tasks specifically? Did the material give examples?
Yeah, things like data transformation. Maybe an API gateway request comes in, triggers a quick process, real-time event processing.
Okay.
Integrating with other AWS services, calling DynamoDB, S3, whatever. Or even things like authorization checks, input validation logic, stuff that needs to run fast, do its job, and get out.
Makes sense. And the flip side, where does that Node.js trade-off hurt? Where would LLRT actually be slower?
The sources are pretty upfront about this. Performance drawbacks compared to JIT runtimes will show up in computationally heavy tasks.
Like number crunching.
Exactly. Think large-scale data processing inside the function itself. Complex simulations, they mention Monte Carlo simulations, or basically anything doing tons of iterations, like loops running hundreds of thousands or millions of times.
Because that's where a JIT would have time to analyze and optimize the code significantly.
Right. For those tasks, the JIT's warm-up time is paid back, and then some, by the optimized execution speed later on. LLRT wouldn't have that optimization boost.
So LLRT is positioned more as a high-performance component within a larger serverless architecture, maybe handling the initial request validation or routing, rather than being the engine for a heavy back-end process itself.
That seems like a fair interpretation of how it's presented, yeah. Complementing existing components, not necessarily replacing a whole application built on Node or Dino.
Okay, practicalities. If you're a developer and you think, LLRT might fit my serverless function, what do you need to know? Compatibility? Workflow?
Yeah, this is super important. The GitHub repo details really emphasize LLRT is not a drop-in replacement for Node.js, not even close in terms of API coverage. It only supports a subset of Node.js APIs. So step one is absolutely checking if the specific APIs your code needs are actually supported by LLRT. You can't just assume.
And what about dependencies? That familiar node modules folder?
The guidance is generally against just deploying a raw node modules directory.
The performance reasons.
For performance, yeah. The recommendation is to bundle your code. Use tools like ESBuild, Rollup, Webpack. The docs have examples to package everything up, minify it, and use tree shaking to strip out anything you're not actually using. Get it down to the bare essentials.
Okay, so bundling is pretty much required. Interesting that they've also built some native LLRT modules.
Yes, they mentioned providing native implementations for common functionalities you might otherwise grab from NPM. Things like fast XML parser or
Nice.
generating UUIDs.
So you could potentially avoid an external dependency there.
Potentially, yeah.
Yeah.
Using the native versions could be faster, but you'd need to check if they have all the features you need compared to the NPM package you might be used to. They might be more focused implementations.
Makes sense. What about interacting with AWS services
Yeah.
using the SDK? That's bread and butter for Lambda.
Right. So apparently, many AWS SDK v3 clients are actually built into the LLRT runtime itself.
Oh, interesting. So you don't necessarily need to bundle them.
Not always. The documentation mentions different bundle types you can choose from, like no SDK, STD-SDK, full SDK, depending on which AWS services you need to talk to. You can save package size.
Any catches there?
One current limitation they explicitly note is handling streaming responses from the SDK. It seems LLRT doesn't support returning the raw stream directly yet. You have to buffer the whole response first, using methods like transform to string or transform to byte array.
Ah, okay. Good to know. What about TypeScript? So prevalent now.
If you're writing in TypeScript, you need to handle the compilation step before deployment.
So transpile it down to JavaScript first.
Exactly. Transpile it to standard ES 2023 JavaScript. Similar to the Node.js philosophy, the source's state TypeScript isn't supported natively at runtime for performance reasons.
Right.
That compilation needs to happen in your build process.
Got it. So how do you actually test if your code, once bundled and transpiled, will even work with LLRT's limitations?
They provide a built-in test runner. The repo describes it. It supports different kinds of tests. Unit tests, end-to-end tests, specifically for checking AWS SDK interactions and compatibility with web standards. They mentioned Winter CG compatibility.
What's Winter CG?
It's basically a community group trying to standardize common web platform APIs across different JavaScript runtimes, including server-side ones. So testing against that helps ensure some level of portability.
Okay. And the test runner itself?
It apparently uses an API style similar to Jest and supports Jest or Chai style assertions, which should feel familiar to many JavaScript developers.
And then deployment, getting it onto Lambda?
The sources list a few options, which is good. You can deploy LLRT as a custom runtime, package it up as a Lambda layer so you can reuse it across multiple functions.
Standard Lambda approaches?
Right. Or include it in a container image if you prefer deploying containers to Lambda. And infrastructure as code tools like AWS SAM or the CDK apparently have specific support or examples for deploying LLRT functions too.
And they mentioned benchmarking, focusing on the full round-trip time.
Yeah, they emphasize measuring the complete cold start duration from invocation to response, not just the internal runtime initialization, to give a more realistic picture of the end-user experience.
Sensible. Any configuration needed. Environment variables.
Yeah, there are environment variables mentioned for controlling things like logging verbosity, network permissions, maybe tuning garbage collection thresholds, that kind of stuff.
Okay. So pulling back to the bigger picture again, how does something like LLRT, this specialized runtime, potentially shift things for developers building JavaScript backends?
Well, it definitely adds another factor to consider, doesn't it? It's not just, should I use Node.js or maybe Deno or Bun for everything anymore.
Right.
Now, if you're building for serverless, particularly on AWS, you have this other option specifically designed for that environment. Node is still likely the default for its massive ecosystem, its maturity, general purpose flexibility. Deno offers its unique security angle and solid performance. Bun pushes the envelope on speed. And now LLRT carves out this specific niche for extreme cold start optimization and serverless cost efficiency.
So the choice becomes much more context dependent.
Absolutely. It really boils down to the specific project requirements, the performance profile you need, the environment you're deploying to.
And what if LLRT moves beyond experimental? If it matures?
Well, if it continues to develop, improves itself, you could certainly see it becoming a first-class standard runtime option within AWS Lambda.
Like selecting Node, Python, Go, or LLRT?
Exactly. And that could potentially influence how people architect serverless JS apps more broadly.
Right.
Maybe you'd consciously split functions, use LLRT for the super latency-sensitive API endpoints, but use Node or Deno for the heavier background processing tasks triggered by those endpoints.
Interesting. Okay, so let's wrap up this deep dive based on the sources you brought. LLRT. It's a really fascinating development, isn't it? Highly specialized.
Definitely. A purpose-built contender for serverless efficiency. And that core idea making a deliberate trade-off. ditching the GIT compiler is the key.
Right. It's not magic. It's an engineering decision targeted at a specific problem.
And while it's experimental now, not a general node replacement by any means, those performance numbers the sources cite for cold starts for resource use, they are potentially very compelling for the right kind of serverless tasks.
Yeah, for specific functions, it could make a real difference. And understanding these nuances, especially that core insight about why removing the JIT can actually be a feature in serverless, that really helps you navigate this increasingly diverse runtime landscape.
It's less about finding the single best runtime for everything.
And more about understanding the specific problem each one is optimized to solve.
Exactly. Matching the tool to the job.
So here's a final thought for you, our listener, to mull over. Building on what we've discussed from these sources, with runtimes like LLRT specializing so intensely for environments like serverless, rethinking fundamentals like the JIT, what other kinds of highly specialized runtimes or maybe deep performance optimizations do you think might emerge next? For what other computing contexts? Something to think about.